discussing about the cleaning and sanitization of the food surface. We discussed about the different detergents that are applied in the dairy industry and the sanitizers and the process of cleaning and sanitization of the food surface with respect to the dairy that we discussed. The part 2 of this class is pertaining to the general principles of cleaning and sanitization in various food industries, mostly the foods of animal origin. That also includes milk. In addition to milk, it is the meat, the egg, the fish, likewise other foods of animal origin. Practically, there is no difference between the vegetable origin or the animal origin foods with respect to cleaning and sanitization of the food surface. The basic principles of the tenets are same, but we need to understand the processes in detail. We are often hear these terms: cleaning, disinfection, sanitation, and sterilization. They are in the order, in the increasing order. They deal with the microorganisms and they remove the microorganisms from the surface, or these processes they inactivate or kill the microorganisms. To begin with, the cleaning. Cleaning is a physical process. Often we may use certain cleaning tools to remove the dirt or dust stain from the food surface. The food surface here is food contact surface. That's what is the process of cleaning. The cleaning is broadly categorized into two: dry cleaning and wet cleaning. Dry cleaning is without the aid of any water or moistening agents. The wet cleaning is aided by the water. That's what is wet cleaning is. So initially we go for dry cleaning followed by wet cleaning, or sometimes only the wet cleaning. So that is depending on the type of the food surface, we apply the dry cleaning or wet cleaning, or both dry and wet cleaning depending on the type of the soil and depending on the type of the food surface. The second process is the disinfection. Disinfection is a process of the elimination of the microorganisms, and invariably we call the surface as non-living. Okay. So why it is non-living? Say for example, we have a similar term, sanitation. In what way sanitation and sanitation or sanitization? Sanitization and disinfection are different. So disinfection often we apply it to the floors or wall, okay, in the food industry. While sanitation, the surface, say for example SS304 food surface, wherein the food comes in contact with. Both will aim at elimination of the microorganisms to the tune of 99.99%. All pathogens and almost all non-pathogens are killed by these disinfection and sanitization process. Disinfectants are a bit stronger compounds and they have a bit longer contact time compared to the sanitation. Sanitation is brought about by in seconds, and disinfection is in minutes. While the fourth step is the sterilization. Sterilization is killing of all forms of microorganisms, whether it is a vegetative bacteria, whether it is a bacterial spore, fungi, whether they are pathogenic or non-pathogenic, they are all killed. Viruses, spores, they are also killed by this sterilization process. Sterilization process leads to the 100% elimination of the microorganisms from the surface. But often it is difficult to achieve in any food surface, in any food factory or food industry. It is very difficult to attain. You know, in the laboratory we use the hot air oven for the sterilization of the glassware, or we use autoclaving for the sterilization of media and all. No organism grows there, whether it is a virus, whether it is a bacterial spore or the vegetative organisms, they all are killed. That is the process of sterilization. So now the point is clear to you. And usually what we mean cleaning and sanitation, these are the two steps that we apply. Even though disinfection is applied to the floor and other things there in the food industry, and sterilization is applied to some of the products. But routine cleaning, when we say maintenance of the hygiene, it is invariably cleaning and sanitation. Because certain of the disinfectants that are used in our toilet or in the office, they cannot be used in the food industry because there can be carryover of the residues. And as I told you earlier, disinfectant agents are very strong chemical agents. They are otherwise toxic. They are otherwise having the food safety concerns. That's why usually we go for the sanitizers in the food industry. The key terms. Cleaning, as I told you, it is application of energy to a surface so that the dirt is removed. Dirt here is the soil, and soil it is anything starting from the residual of the food to any extraneous matter, what we call it as the soil or the dirt. This dirt has to be removed. This process of removal of dirt or the soil is the cleaning, and it is applied in two ways: dry cleaning and wet cleaning. And we apply energy to ensure the cleaning of the surface. The kinetic energy, such as physical, mechanical, or turbulence energy, or thermal energy, such as the heat, or the chemical energy, such as detergents, are used to cleanse the surface. And come to the sanitation. Sanitation or sanitization is a process of reducing the microorganisms to the tune of 99.999%. All pathogens are killed, and almost all non-pathogens are killed. But some of the viruses, very resistant viruses, and some of the spores are not eliminated by sanitization process. And you see that action within 30 seconds, sanitizer brings about the sanitization effect. While disinfection, it is using bit stronger chemicals or stronger agents so that 99.999% of the organisms are eliminated between 5 to 10 minutes time. And the difference basically, if you talk about the heat or a steam, is it a sanitizer or a disinfectant? It can be used as a both. So as I told you, disinfection is mostly non-living surface that won't come in contact with the food directly. We apply disinfectants there. And the surface that comes in contact with the food, we apply sanitizers there. Otherwise, these are milder chemicals, sanitizers, while disinfectants are stronger chemicals. And invariably, with respect to the disinfectant agents that are applied in the food industry, there is restriction on certain chemicals to the food safety concerns because they themselves would not act as a toxicants. While all sanitizers are food grade. Okay, food grade means even if very minute traces they remain, they will not constitute serious health hazard in the human consumers sanitizers. That's why I told you mild. So the levels of the clean, when we say it is the cleaning, disinfection or sanitization and sterilization. Then why we have to clean and sanitize? If you want to clean and sanitize the food surface after its use, there is a buildup of the microorganisms, and these microorganisms would lead to the transmission of the disease process, or they would spoil the product. And when the product spoils and it lacks the shelf life, there is the loss of the brand image in the market. When the brand image is lost, then marketability is affected, so leading to the loss to the farm. That's why we have to maintain very high level of cleaning and sanitization in any food factory. If you won't clean properly and regularly using a suitable hygiene program in the food industry, there is built up of these microorganisms. These microorganisms, the planktonic microorganisms, they settle on the food surface, leading to increase in their number, colony formation. This colony that is formed, we call it as a biofilm, biological film, a thin sheet that is formed. And these are very difficult to remove. Single, the sessile organisms when we talk about, and when you compare it with the planktonic cells, the cells that are adhered to the food surface, they congregate, making a mass, and this biomass, the heat and other chemicals will not penetrate into the deeper aspect of this one, leading to the source of contamination of the product on its subsequent use. That is why these complex aggregations should be removed, should be removed. So that's what is the requirement. That is what is the requirement in the food industry. So in order to manage these complex matrices in the over the food surface. And routine cleaning and sanitization process, or the program what we build. Why it is a program? It is implemented and it is monitored and it is ensured and demonstrated to the third party. That's why it is cleaning and sanitization program. And many of the inspections in the food industry are based on the hygiene. The hygiene is checked, cleanliness is checked, so that the product that is offered to the public would not lead to any deleterious effect, or the product has good shelf life later on. So cleaning and sanitization are complementary processes. Without cleaning, sanitization is incomplete. So the cleaning process is a prerequisite for the sanitization. What all should be cleaned and sanitized? Any food surface that comes in contact with the food directly, okay, wherein the product is handled, the receptacle or the food surface in which the product is handled, that is direct. Indirect is the other surfaces. Other surfaces means the floors, the walls, the other things that are there in the food factory. So these are the, say for example, the coverings of the drainages. All of them should need to be cleaned and sanitized on a regular basis. Then what is this frequency of cleaning? That depends on the product that is handled in them. For example, the floor cleaning. Floor cleaning can be done intermittently or terminally. So terminally in the sense, say for example, 8 hours or 4 hours, whatever the shift is over. At the end of the shift, the floor and walls can be cleaned. And they are cleaned just before use and the operations start in the factory. So like that, any food surface here is the utensil surface. If it is a meat, they are like a knife, the tables, the cutting boards, the conveyor belts, the ice makers, the ice storage bins, the hands of the people who work in, the gloves that come in contact with the product, the aprons. So all of them should be cleaned and sanitized. Okay. And sometimes, as I told you, the surface that won't directly come in contact with the product, such as wall, ceiling, floor, tiles, following a cleaning and sanitization program in a factory. And as I told you, as a requirement of the quality assurance, it is checked, inspected, and assured. Okay, using suitable laboratory test that should be assured. Okay, whatever cleaning is there, that is efficient like that. At times, we use the several cleaning tools. Okay, cleaning tools such as brooms, the mops, the squeezers, the buckets, the sponges, scrapers, the foaming equipment, the water guns, they also need to be cleaned and sanitized. It is not the cleaning of food surface such as the floors, ceilings, walls. It is those tools that are used to ensure this cleaning process. They also need to be cleaned and sanitized. So that is the third requirement. One is direct food surface. Second is the surface which is indirectly that is influencing the product. And the third is these tools that are used to achieve the cleaning and sanitization. They also need to be cleaned and sanitized. That's also a requirement in the food industry. All these tools must be cleaned at the end of their work, okay, sanitized, kept dry before they are reused for that purpose, because they are not disposable, right? Okay, they are not disposable until they are, depending on the product of the tool type, they will have certain life until that is completed. So they are used, and at the end of their use, they are cleaned and sanitized so that they are again kept ready for the reuse. And as we discussed previously, there are various factors that influence cleaning and sanitization process. Okay, the type of the soil, is it organic, inorganic, condition of the soil. Okay, so old soils are very difficult to clean. If it is the soil is in the form of a milkstone, still difficult. And if you are using the hard water for achieving that, still more difficult. Okay, so what is the water temperature that is beneficial for achieving the cleaning process? Is cleansing agent is having the surface active agent, so that more agitation is brought about, more pressure can be applied, so that the heat or the chemicals will go for the deeper penetration into the soil. And what is the length of the treatment? Longer is beneficial, but at times longer is not possible because immediately the next shift has to be started. Under such circumstances, we have to select such a agent that brings about the activity in less time. Sometimes the product, if it is let like that, so there can be damage to the surface. Under such circumstances, you have to have your own exercise homework in deciding the correct cleaning and disinfection or sanitization program for the particular plant. And at times it depends on certain cultural, religious, and traditional values also. When the traditional foods are prepared, so these things also need to be kept in mind. The climatic conditions, the infrastructure, and other aspects of the food unit, they all have their own bearing in the selection of these disinfectants and sanitizers or the detergents that are used for the cleaning purpose. Then let us understand some of these definitions. Food. Any food which is consumed by the humans. Okay, that's what is the food. Whether it is a whole food or a component of a food. So they are all considered as foods only. Okay. Then food transportation unit. Any unit that carries the product from one side to the other side is the food transport unit. Okay, let it be the truck, let it be rail, let it be aircraft, ship, container, all that is the food transportation unit. Then we categorize foods as perishable and non-perishable. Majority of foods of animal origin are perishable in the nature, means they spoil early if kept at room temperature for some time. This spoilage is brought about by the microorganisms, their activity themselves, or the enzymes that are liberated by these microorganisms, which are proteolytic, lipolytic, or saccharolytic, leading to the deleterious changes in the food product. Such product, we say that when these products are accumulated in the product, we say that the food has lost its shelf life. Such product is a perishable food. Okay. Then potentially hazardous food. What is this potential hazardous food? A food which is having in it the pathogenic microorganisms. When they are ingested, they cause the disease, or there is production of the toxins. Okay, when human being consumes such food, it would lead to disease in the form of infection, intoxication, or toxin infection. That will study a little later. Such a food, we call it as a potentially hazardous food. And when a food is potentially hazardous, the persons who are manufacturing or the unit that is manufacturing is the thing that is responsible. And any loss that occurs, say for example, I have brought some mango juice and I consumed some 100 ml of mango juice and I suffered from gastric upset. Okay, that is one scenario. Second, I took it, I consumed it and I died. Okay, death. One more scenario. Or it has affected the reproduction ability, production ability, or loss of eyesight, whatever may be the danger. Okay, depending on the danger, the penalty is imposed. Okay, at times a mild diarrhea is caused without any health upsets. At times death occurs. So potentially hazardous food is a bit subjective. It is subjective in a way that how much danger or damage is risk that is caused by this hazardous substance, that determines the amount of penalty to that. Just to give an example, there was an outbreak of salmonellosis in America, and that egg supplying company, number one, its license was cancelled. It can no more continue in the food business. Second, penalty was imposed, a huge penalty, billions of millions or billions of penalty was imposed. Okay, you have to sell the factory and then you have to meet that penalty. And third, imprisonment to the person, the highest owner of that. So in that way, the potential hazardous food has got, in addition to some moral aspects associated with that, it has a legal aspects and it has the imposition of the punishment in terms of fine or imprisonment. That's it. Cross-contamination. Cross-contamination is a process wherein there is a cross-transfer of the microorganisms when foods are handled in a unit or a plant. So it should be zero. Cross-contamination should not occur in any of the food processing, production or processing units. If it happens, that is a very poor unit and it is a major non-conformity with respect to the production of that particular food product. The basic principles of cleaning we discussed, and cleaning, then sanitization, then drying. These are the processes, and in doing so, in order to remove the soil, there are certain factors that need to be understood. We call them as the Sinner's circle. Okay, temperature, time, mechanical action, and chemical action. In order to remove whether it is a soluble material or insoluble material, that is nothing but the soil. There is a lot of science that is involved behind the cleaning process. Okay, if the type of the soil is oily or fatty, okay, the type of the process that you are going to apply, or the same process, the time temperature combination that you want to apply will be different compared to a proteinaceous soil and when it is compared to the carbohydrate type of soil. Carbohydrate soil type of soil, when it has not been subjected to the higher temperature, is very easy to remove compared to the proteinaceous. Okay, and oil and fat. Oil and fat tends to adhere to the surface. Okay, you need such a process wherein there is no residual lipid that remains. Otherwise, that is associated with the smell, or it is associated with the microbial growth or transitive changes, which are detrimental. Then the cost and productivity is also a very important thing. Okay, so we have to apply strong science in achieving the cleaning and sanitization process within the food industry. And current requirements of the industry also like that one. Okay, whether it is any quality assurance programs or let it be Food Safety and Standards Authority of India, all of them they recommend that. So the proper cleaning and sanitization, they must be implemented in any food production unit, let it be the animal origin or let it be the foods of plant origin. So what kind of materials should be used for cleaning sanitization? What should be the kind of the food surface? What kind of the manual or the machine cleaning has to be implemented? What kind of the process control that needs to be established? And how it has to be demonstrated to the third party? All these things are very much essential in any food production unit. Otherwise, that particular unit will not be permitted, or will not be fit for operation of the processes leading to the production of the varied food products. And as we discussed earlier, the results of improper cleaning these are all the built-up of the microorganisms, loss of the shelf life, and a lot of consumption of the other components such as the energy consumption, such as the detergent consumption, the sanitizer consumption. So they are not, and ultimately what will happen? The product's name gets spoiled in the market. On the other hand, if you go for well-designed cleaning protocol, so one thing is the material food surface that you are using, its efficiency will be more, the energy will be more efficiently used off, then all these detergents or sanitizers are used at their optimal concentration, so there is no wastage. Okay, so sufficient concentration so as to ensure the effective cleaning. That's what is the requirement. So they are all attainable when a robust or suitable cleaning and sanitation program is implemented in any food industry. While taking all these precautions in the sense all these steps that are associated with the proper cleaning and sanitization when they are used. So this is the one, and this is the generalized. We discussed it for the dairy, but again same 5 steps that are implemented in any cleaning and sanitization process. Cleaning is first and then sanitization. So clean first, pre-rinse with water, tap water, detergent application. You remove all detergent by the rinse, okay? Then apply the sanitizer. Give one more rinse to eliminate this sanitizer, okay? Dry it. So that's the way to achieve the sanitation. So the dry cleaning, we already discussed this one. Dry cleaning first, then pre-rinsing. After this pre-rinsing, the actual cleaning process to remove the soil. So that again depends on various physical and chemical properties of the soil. Then once this cleaning is over, so the remnants of the detergent and all those things detergent with the soil has to be eliminated by this rinsing process. Then once all of them are removed, so sanitization and after sanitization drain. And in the cleaning step, cleaning can be again further categorized into two. One is the primary step and second is the secondary step. What is this primary step? Primary step is removal of soil from the substrate. Substrate here is the food contact surface. Secondary step is stabilization of dispersed or dissolved soil in vast liquor to prevent redeposition. Earlier, whatever that was there, visible and other things, that was removed. Gross. Second one is more deeper. More deeper one is something which is not visible, something that cannot be removed by the mechanical processes. We make them dispersed or dissolved, okay, in a liquor, and this liquor is flushed out. That is the secondary step. So we sometimes these two are sub steps of the cleaning, or at times they go hand in hand. Okay, but if it is preceded, primary step is preceded by the secondary step, that's good. Okay, ultimately all that soil with the help of the cleansing agent is a detergent. So when a detergent penetrates deeply into the soil, it dislodges from the surface, and later on that is dispersed, and with a flush of water, with a rinse of water, that is taken out from the food surface, and it that gets rid of that. The 4 categories of common cleansing agents are the detergents, the solvents, the abrasive type of cleaners, and acid cleaners. So we'll not go into details of these things because those things we already discussed previously. Okay, in general, we use the general purpose detergents or alkaline detergents or chlorinated type of detergents, acids, or sometimes even we use the enzymes to achieve this cleansing process. Okay, so some enzymes also can be used. Okay. The solvent cleaners are nothing but the degreasers. Okay, degreaser means the fat has to be removed, and we use invariably alkaline type of detergents to saponify the fat and remove the greasy material present on the surface of the food surface. The acid cleansers are very much useful in removing the mineral deposits. Mineral deposits means the milk stones, and likewise the scales that are formed on the surface. Okay, let it be the food or even water. Abrasive cleaners contain silica. Okay, abrasion. They bring about the mechanical action and dislodge the soil from the surface. So whenever we apply these detergents, the contact time, temperature, and physical force that is applied, and the water chemistry, because after all, without water cleansing is not possible. Okay, so when we talk about the water, if water itself contains certain dissolved minerals, then it is very difficult because it itself leads to the formation of the scales, which is not accepted. So that's why the chemistry of the water is very important. The temperature is also very important. Okay, the mechanical disruption that we achieve, that is important. The post rinse. Okay, in this post rinse, what are we removing? We are removing the detergent. Okay, and this detergent, where it is present along with the loosened soil. Both are present on this contact surface. They have to be removed. At the end of this process, step 4, neither dirt remains on the food surface nor detergent remains. So that's what is the thing that we have to ensure. When there is no detergent and when there is no dirt that is available, then you go for sanitizer. So that the sanitizer will go for the deeper penetration. And it is, if at all any organism which is present on the surface, that is killed there itself. And if possible, is rinsed after this process. Okay, when you apply the hot water or the steam, that is removed. Okay, that's what is the requirement of sanitizer. Without doing the cleaning process, if we apply sanitizer, what will happen? The sanitizer itself will get inactivated by the physical and chemical action brought about by the soil. The sanitizer will not be effective enough. And one more thing, you keep it in mind, sanitizers will not be that cleansing the way the detergents are. The role of the detergent is to cleanse the surface, while the role of the sanitizer is to eliminate the microorganisms to the tune of 99.999%. So the role played by a detergent and the role played by a sanitizer are different. Invariably, we use the quaternary ammonium compounds, which are very strong enough to bring about the sanitization. We call them as quartz, quaternary ammonium compounds, or simply quartz. Okay. And how to ensure that the surface has been properly sanitized? So we ensure by using certain chemical or certain automated testing systems. Okay, what are those? We'll discuss a little later. Okay, but the sanitizer, if at all, it has to bring about its action. It should have all these ideal properties that we discussed earlier. And commonly used sanitizers in the food plant include the chlorine, quaternary ammonium compound, peracetic acid. These are very common, although the list contains chlorine, iodine, quaternary ammonium compounds, chlorine dioxide, and peroxyacetic acid, PAA. But very common are chlorine, quat, and PAA. They are very much used. And at what concentration they are used? Remember this. This is very important to you because you have to remember this. If a food surface comes in contact with the food, rather, if a contact surface comes in contact with the food, that we call it as a food contact surface, we can use at the rate of this chlorine 100 to 200 parts per million the available chlorine. On the other hand, non-food contact surface. Non-food contact surface means the floor, the wall, ceiling. This is what is. Plant water means the water that is supplied in the plant, because obviously you cannot provide the sterile water to the distilled water to the plant. No? After all, you supply the water from any water source, such as the groundwater source, bored well, okay, or the surface water, which is rendered safe by the treatment, municipal supplies. Under such circumstances, microorganisms are present even in the water. This water requires chlorination, okay, plant water. So the available chlorine should be 3 to 10 ppm. In domestic supply, it is around 0.5 ppm is the residual chlorine that is present. Okay, you have to increase that some more. Okay, many times, for 3 to 10 ppm. So then that becomes a plant water. So chlorine is very ideal and one of the most highest used sanitizer in the food industry. Okay. Then comes QAT. Quaternary ammonium compounds are applied at 200 ppm, 400 to 800 ppm non-food surface. Okay. Then peroxyacetic acid PA 200 to 315 ppm, and non-food surface also same concentration because they are very effective at that particular concentration. So chlorine, QAT or PAA are commonly used sanitizers in the food industry. Iodophores can also be used. There is no problem. They can be used, but they are not that popular like chlorine. Okay. Chlorine can be applied, as we discussed in one of the class. Chlorine can be applied as a gas, as a liquid, as a solid. Solid means bleaching powder. And it kills majority of the vegetative microorganisms. However, chlorine is ineffective in killing the bacterial spores and certain viruses. And chlorine being the reactive halogen, it corrodes the metals and it weakens the rubbers. And chlorine handling is difficult because it irritates the eyes, throat, and this chlorine handling again, it is unstable. Okay, so that's why, and pH sensitive also. Extremes of the pH, the chlorine won't work. So that's why chlorine, even though this is having these many limitations, owing to its ease, economical applications, and variety of formulations available in the market, all of them, they make the chlorine as an ideal and top one choice for the sanitization of the food industry. Then comes the iodophores. Don't confuse iodophore with iodine. Okay, it is iodine dissolved in surfactant and acid. That's what is iodophore is. Surfactant is very important because if mere iodine is not going to help in the food industry, and it kills most compared to chlorine. Iodine is most strong. Okay, it is less pH sensitive than the chlorine. Okay, so but the disadvantages of this iodine are, so alkaline pH, it is less effective, and it is unsuitable for CIP. Okay, because iodine, this iodophores, since they contain this surfactant, so they are foaming, and this foam is a bit difficult to remove. That's why iodophores are not used. One more major disadvantage with the iodophores is that the staining of the surface. You know that iodine itself is colored one, so there is a brownish stain that occurs on the surface. While chlorine, no stain because it is colorless. Quaternary ammonium compounds are still more stronger sanitizers compared to the chlorine or iodophores. Okay, benzalkonium chloride or related compounds, we call them as QAC or QATs. They are very much used in the industry. However, in presence of organic matter, their effectiveness gets reduced. And if not properly rinsed, their residues that remain on the food surface have food safety concerns. Okay, and the disadvantages of the quaternary ammonium compounds include they are inactivated by most of the detergents. Nobody adds detergents here over the food surface, but the remnants of the detergents, if at all, they are remaining. Okay, so when the sanitizers are applied, they become ineffective, and it is inactivated by the hard water. At times, even though softeners are installed to remove the hardness in the water, okay, sometimes some ions that will be still present in the water, they will be inhibitory to the action of or activity of the quacks. And when it comes to the CIP, a good number of quacks are foaming agents, so that's why this foam itself inhibits them to be used in the CIP. Then the last is acid. There are some more also. Acid anionic type of sanitizers. Okay, they are coupling of these compounds that can be manufactured by coupling surfactants with the acids. Okay, and the advantages and disadvantages of them are given over here. Peroxy compounds, because this is a very strong oxidizing agent. Okay, and it is effective against the biofilm and kills most type of microorganisms. and at low temperature the action is brought about. Okay, and meets the discharge requirements. Okay, discharge in the sense effluent, and low foaming. Okay, it is more suitable for CIP next to the chlorine. Okay, and the disadvantages are bit expensive. Carboxylic acid, the phenol, it is not that popular. Chlorine dioxide is a gaseous form of the chlorine. Ozone, no germicidal action that is left as a residual effect. So unlike chlorine, if it is a chlorine, there is a residual effect due to the residual chlorine that is remaining. Ozone means at a point in time. Okay, and it is very strong oxidizing agent, ozone. Hot water is best. Hot water or the steam is best because there are no issues associated with that. But only major drawback with production of hot water is the energy that is required to heat the water. That's the problem. So there is a detailed discussion on chlorine sanitization. We'll discuss little later. We deal with the water. But at this point of time, we just understand that the chlorine and ammonia should not be mixed together. That's the rule in the dairy industry. Dairy industry or any food industry for that matter. Okay. The next thing associated with the chlorine is the hypochlorite. Hypochlorite in the sense, as I told you, when the bleaching powder or chlorine dioxide gas is introduced into the water, H2O plus Cl2 leads to formation of HOCl, which is nothing but the hypochlorite, and that has the germicidal activity. Chlorine dioxide gas that is produced. Okay, that's cylinder. Okay, that's kept in the cylinder, and it gets mixed in the water, dissolved in the water, leading to liberation of the chlorine. That chlorine is the germicidal in nature. Quaternary ammonium compounds, they are good one against the pathogenic organisms and even the contaminating organisms. They are good. Okay, they can also be used as a footbath floor. They can be applied on the cooler surface. Okay, they are all good one. But only problem with quaternary ammonium compounds is there's cost compared to the chlorine. They are costly. Iodine based advantages and disadvantages we discussed earlier. The major problem with iodine based means iodophores is that the foaming, and second problem associated with these kinds of sanitizers is that the staining of the food surface and their unsuitability on certain food surfaces. Regarding acids, we have used in detail, but carboxylic acid is not used on the food surface. Okay, rather peracetic acid is produced. Okay, how this peracetic is produced? When hydrogen peroxide is mixed with acetic acid, so peracetic acid is formed. The other kinds of sanitizers that would be used are the ozone, UV light, and the hot water. Regarding hot water or steaming water or boiling water, that's there in the disinfection action. The ultraviolet light, we can use it for the air, but not on the food surface because the penetration power is not there with respect to UV. And the UV lamps lose their life at times, requiring replacements. And ozone problem is that there is no residual effect. Okay, so like this, the sanitizers are applied by various ways, either as a single entity or they are compounded with other substances. They can be applied as a liquid, they can be applied as a gas also. Okay, so in the form of a mist, fog, so like that also they can be applied. So it is the flow. Okay, this cartoon or the image shows the food contact surface. They initially go for the cleaning. Okay, cleaning, rinsing, detergent, and then finally rinse the detergent and go for the sanitization process. The different kinds of cleaning are, as I told in the beginning, the manual or mechanical cleaning. Manual means with hands, okay, or using tools. Mechanical means using machines. Immersion cleaning is one more type. Just immerse in this tank and get it clean. Cleaning out of place, COP means cleaning out of place. Dismantle the instrument and bring it to the dedicated cleaning area and you clean that. That's what is cleaning out of place. Then CIP is cleaning in place wherever without dismantling that. And in achieving the cleaning, these high pressure sprays are of great help. Then wet vacuum cleaning is also there in addition to the automatic scrubbing. So the advantages of manual cleaning is that it's easy. Okay. The disadvantage is that there is human error. While mechanical cleaning and sanitization are good. Okay. So when they are used with a pressure, that is still good. Okay. Foam cleaning is one more process wherein there are two ways by which the foam is applied. One way is that at the end of the work, entire unit gets the foam through the centralized cleaning systems. Okay, that's what one way. Second one is the decentralized foam cleaning systems, wherein you can see the connectivity here. So the foam generator gets connected to a pipeline or a system. So wherein wherever that is required, foam cleaning is done. That is decentralized. Centralized one means it is there and it's going to cover the entire area. Then when it comes to dry cleaning again can be manual or the automated one. So depending on the food surface, the level of mechanization in the plant, these things are applied in the food industry. Okay, there is no fixed thumb rule. The general principles are alike, but it should be used like this only. There is no generalized rule for that. And regarding immersion cleaning, I talked about it is cleaning out of the place, contrary to the cleaning within the place. So you dismantle the unit, bring it to the cleaning platform, and there you clean it. That's what is the cleaning out of place. The cleaning out of the place can also be hastened using the jet action. You can see here the jet action with a lot of pressure. The swirl or the whirlpool is created wherein there is cleaning process that occurs. Push-pull type of devices wherein the mechanical scrubbing occurs, or combination of these two, jet action along with push-pull type of systems that can be applied. Regarding cleaning in place, we discussed in detail about this one. Using a suitable circuit, there is recirculation of the acid, alkali, detergent, and the water. So at a particular time temperature combination. Okay, finally all that waste that goes to a drain. So, but this recirculation time 15 to 20 minutes that is kept until the desired output that comes in with respect to the surface. And while using these CIP, one thing that has to be kept in mind is the strength of acids and alkalis that has to be maintained. Okay, there is sometimes the addition of some more alkali, some more acid that is followed. Okay, at some places depending on the type of the food surface. High pressure cleaning is beneficial in the food industry. Wherever possible, it must be used because only thing is the food contact surface should sustain that pressure. That's very important. If we apply a very high pressure and the food contact surface won't sustain that, or it gets dislodged from that place, or there is mechanical wear and tear, then we cannot use the high pressure cleaning systems. Okay, when the food contact surface is robust enough, it can sustain the pressures, then at the least cost, because the pressure itself aids in the cleansing process, so we can implement such systems. And how to ensure that the surface has been properly cleaned and sanitized? We have various systems for that. One is the visual testing. Using the experts, using their expertise, they will say that whether the surface has been properly cleaned or sanitized or not. Okay. The second is general appearance. Okay, is there any dirt that is remaining, any soil that is remaining at the end of the cleaning and sanitation process? That's what is general appearance. However, we rely on the microbiological and non-microbial based tests. Non-microbial based tests are enzymatic based tests, ATP bioluminescence based tests. Okay, these are the non-microbial in the sense there is no conventional microbiology associated with the detection of the organisms or the food surface. But the classical techniques are the microbiological test. They are contact agar method. You take a petri dish, okay. Over that, you just take you prepare a mold of the agar, bring in contact with the food surface. That one you put it over the agar, count the colonies. That's what is the contact agar method. Even we use the sausage also for that purpose. Okay, so that's one contact method. Next is agar sausage method. What we call it. Then rinse or swab method. You take a swab and you particular area, okay, 900 square centimeter or 25 square centimeter area, depending on the food sample. You take the swab by taking into account the entire sampling, and you put it over the diluent, and then you put it over the agar. That's the way in which we go for enumeration of the organisms. The second is the rinse method. Take a known volume of the diluent, see that it gets the utensil, you put it in the utensil or food contact surface, rinse it properly, collect that, and a representative portion or the entire portion you put it over the just like standard plate count you perform and know the microbial. Then rapid hygiene test. So rapid hygiene test, there are so many chemistries associated with that. We'll discuss about these tests in the laboratory class in detail. Okay, and we need to monitor the detergents. We need to monitor the sanitizers. We need to monitor the foot baths that are applied at the entrance of a unit. Unit in the sense a particular section of a food plant. So what is the chlorine concentration? Is it 200 or not? Is it 100 or not? For that, certain rapid tests that are available in the market, they can be used. The swabbing, details of swabbing we study, as I told you in the practical, we will study. But at this point of time, swab can be taken from the food surface for enumeration of the microorganisms in the laboratory. Okay. However, these conventional microbial tests have limitations, because if the organism is dead, it is a stressed, okay, or non-cultivable type of organism. The organism will be there, but the microbial test will be negative. So then we will go for the ATP bioluminescence or luminometry, okay, or other kinds of the advanced tests to ensure that the cleaning and sanitation processes has been achieved. Okay. In addition to this, we go for the strength evaluation of the strength of the disinfectants or the sanitizers that are used in the food industry. Okay, so there is microbial aspect that is associated with the ensuring of cleaning sanitization, and there is non-microbial aspect also. Then these cleaning and sanitization process that are applied in the form of a cleaning program or hygiene program, and they run through a specific standard operating protocol. And this standard operating protocol, SOP, has to be tested and has to be demonstrated to the third party on demand whenever there is inspection of the plant. That is very important. So it is cleaning and sanitization is not only to build the brand, but also as a basic requirement under the quality assurance schemes. It is a basic requirement when we talk about implementation of the food safety management system to any food industry. Okay, so this is all about the schedule, and it has to be documented, and it has to be evidence has to be demonstrated. So this is in nutshell about the cleaning and sanitation of